This video is about database normalization. My name is Jeffrey Tolentino. This is a requirement for the subject DCC 103, Advanced Database Management System, under Dr. Rosana Esquivel. So let's start. The question is, what is normalization? We have three definitions here. So the first one, from techopedia.com, according to them, normalization is the process of reorganizing data in a database so that it meets two basic requirements. Number one, there is no redundancy of data. And the second one is data dependencies are logical. According to livewire.com, normalization is the process of efficiently organizing data in a database. There are two goals of the normalization process. Number one, eliminating redundant data, and the second one, ensuring data dependencies make sense. And now, according to Microsoft, normalization is the process of organizing data in a database. This includes creating tables and establishing relationships between those tables according to rules designed both to protect the data and to make the database more flexible by eliminating redundancy and inconsistent dependency. There are two key terms that we can take away from these definitions. One is redundancy of data, and then the second one is data dependency. So let's talk about them. Data redundancy simply means duplication of records. It's as simple as that. Normalization aims to eliminate this, and that is all data should be stored in only one place. In this example, under the course column, BS in Information Technology have been duplicated several times, as is with the subject column and the instructor column. There are inherent problems with regards to data redundancy. Number one would be waste of storage space. In this particular instance, the course under the course column, BS in Information Technology data have been duplicated 3 times, and that is a 300% increase in storage capacity needed for storing that particular data. And you have to remember that most databases will contain thousands, if not millions, of records. And if data redundancy is so rampant, you'd be wasting lots of storage space. Another problem with data redundancy is CRUD anomalies. CRUD stands for create, read, update, and delete. Now, anomalies regarding the creation, the reading, updation of and deleting of records would be inevitable in the case of data redundancy, because simply because of the bulk of records being kept. And the effect of CRUD anomalies will be data inconsistencies. An example would be, let's say, teacher ITX, who is teaching programming 1, decides to leave the company, and teacher ITY is tasked to take over the subject of teacher ITX. In this case, there are two students taking up programming 1, AFU and SIFU. Now, if we need to update the record, or we need to update the database, if somehow the one in charge of maintaining the database somehow wasn't able to update the record of SIFU, then we will have an inconsistent data in the database, and that is just an example of how CRUD anomalies would reflect on the database. Now, data dependencies simply means that one or more attribute uniquely identifies other attributes of a relation. In more simple terms, we can say that some data values are dependent on other data values in order to get recognized. We will talk about this later, but in this example, AFU, we have two records here. AFU, the record number 1 and record number 3. It is not uncommon that two persons will have the same name. How would we know that a foo is only a person, or in this case there are two a foo persons in our record? So uh, we can answer that by using data dependencies. Later we will talk about that. There are several types of normalization. We have the first normal form, we have the second normal form, and we have the third normal form. Those forms are pretty much the standard way of normalizing the database. The following are rarely used. We have the BCNF, or the Boyce Code normal form. We have the fourth normal form and the fifth normal form. In this video, we will only tackle the first, second, and the third normal form because of time constraints. So let's start off with the first normal form. No, I'm sorry. Uh, let's talk about three normal forms first. The three normal forms, the 1NF, 2NF, and 3NF, were derived in the early 1970s by the father of the relational data model, EF-Cod. Today's relational database engines use his rules, although some relational database engines do not strictly meet the criteria for all rules of normalization. An example of this would be the multi-valued fields feature, which was introduced by Microsoft in their Access 2000 database application. So, although most DBMS now uses his rules, EF Code's rule, but there are some minor alterations to his rules. So let's talk about the first normal form. This is the basic requirement for a database design. There are four rules that a table should follow to be in the first normal form. The first rule is that each column should contain atomic values. When we say atomic values, it should contain only one value for a particular column, and that value should and can stand on its own. The second rule is a column should contain values that are of the same type. So if you have a column for a date of birth, that column should only contain dates and no other types. Rule number 3, each column should have a unique name. Now most DBMS will not allow you to have duplicate names, so this will be easy to get. And then rule number 4, order in which data is saved does not matter. So let's have an example. In this case, the student table is in the first normal form. The reason for that is for rule number 1, each column should contain atomic values. Now, in the case of Afu, he is the student is enrolled in two subjects, Programming 1 and IT Fundamentals. Now, you cannot put those two subjects in under one row. Otherwise, you would have a field that is not atomic. That means for the subject code, you'd have two values stored there, Programming 1 and IT Fundamentals. That is the reason why we in this particular table, we have two records for Afu. One is he's enrolled in Programming 1, and the second one is that he's enrolled in IT Fundamentals. Rule 2, a column should contain values that are of the same type. In this case, we've achieved that. Name, for the name column, we use the string type, as is with the course column and the subject column. Rule 3, each column should have a unique name. So name is the name for the first column, the course, and the subject. And then lastly, order in which data is saved does not matter. Defu, the record for Defu could be placed in the first row. Doesn't matter once we've queried the database regarding Defu's record, it will still show that he is enrolled in BS in Information Technology, and he has a subject IT fundamental. He's enrolled in the subject IT fundamentals. So it doesn't matter where D4 row is located in the table. It will always show the proper records for him. Let's talk about the second normal form. There are only two rules that the table should follow to be in the second normal form, and that is it should be in the first normal form, and then the second rule is it should not have any partial dependencies. So let's talk about partial dependencies. So what are dependencies again? Data dependency means that one or more attribute uniquely identifies other attributes of a relation. In more simple terms, we can say that some values are dependent on other data values in order to get recognized. So how do we do this? How can we achieve this? We can achieve this through the use of primary keys. The primary key of a relational table uniquely identifies each record in the table. Primary keys are the unique links to related information in other tables. If you have several tables in your database, you use primary keys to link up or relate other tables to other tables. Each table in the database has a column or two specifically for the primary key. Now, in our first example, in the first normal form, again, the question arises, is Afu a single person, or is it possible that there are two persons in the table with the same name? Now, we can classify, or we can uniquely identify a particular record in the database or in the table using a primary key. A primary key is simply another table that is used to uniquely identify a record. So for example, in this particular record, we have the student table. We've added a column, a student number column. Now, the student number column uniquely identifies a foo in this particular instance. If I query the student number 101, it will always show a foo. Now, in this example, this particular table is not in the second normal form. The reason for this is because of the course and the subject columns. Now, the student number primary key identifies the student's name, but it does not identify the course and the subject, which means if I query the student number 101, it doesn't necessarily mean that I will always get the BS in Information Technology course or the BS in Computer Science course, because the student number 1 or the student number 101 only reflects a particular record, and that particular record is in relation with the column name, as is with the case with the subject. If I query a particular student number, it wouldn't really mean that it is related to a particular record in the subject column. Now, we can achieve the second normal form for this example by simply dividing our table into several parts. This is the revised student column, student table. If I query student number 101, I would always get a foo. If I query student number 102, I would always get the foo. Now, one advantage of using this particular instance is that now you've eliminated the need to duplicate the record of a foo, as is with the case with this particular example. A foo is stored in rows number 1 and number 3. In this instance, a foo is now stored in only in row number 1. But what happened to the course column and the subject column? Now, again, we can achieve the second normal form by dividing or by separating this table into several tables. We can add another subject table in our database, and the subject table would contain the subject code, the primary key for each subject. For example, programming 1, we can specify the subject code for that, IT 101. For logic design, CS 201, and then IT fundamentals, IT 102. How can we then relate these two tables, student table and subject table, such that we would know that student number 101, AFU, is enrolled in IT 101, which is programming 1. We will need another table for that, and we will name that table student subject table. Now, again, student number 101, which is AFU, is enrolled in the subject IT 101, which is programming 1. Using these three tables, we can now identify whether a particular student is enrolled in a particular subject. Now, in this instance, I've included a primary key for this table, but in fact, you can delete this, or another strategy for doing this would be to not include another primary key for this one, because a student, when you combine the student number and the subject code together, it can provide a unique primary key by combining these two columns. So it will be up to the database designer if you still need an additional column to specify a primary key, or you can have several columns to uniquely identify a particular record. Now, in this case, the same strategy could be applied for the course column. Now, the third normal form, there are two rules that you need to follow for a table to be in the third normal form. Number one, it should be in the second normal form. And then number two, it should not have any transitive dependencies. Now, we've already talked about partial dependencies. So now let's talk about transitive dependencies. A transitive dependency is a functional dependency which holds by virtue of transitivity. In mathematics, a binary relation R over a set of X is transitive if whenever an element A is related to an element B, and B is related to an element C, then A, by virtue, is also related to C. A transitive dependency can occur only in a relation that has 3 or more attributes. Okay, this is an example of transitive dependency. Suppose you have 4 columns in a table. We have book, genre, author, and author nationality. The functional dependency book knows author nationality applies. Why? Because if we know the book, we know the author's nationality by virtue of the following conditions. The book knows the author. The author does not know the book, but the author knows the author nationality. Therefore, book knows the author nationality by virtue of the transitive dependency. So those are the three examples of normalization: the first normal form, the second normal form, and the third normal form. Credits should also be given to this site. Thank you so much.